All right, in problem number 53, we've got a problem statement here where Matthew is visiting Gregory at his house on North Street. They're probably doing calculus problems together. And Matthew left, and Greg realized, hey, Matt left his wallet here, so he decided to chase him down. But by the time he realized that Matthew had already turned the corner, Matthew was heading east on East Street, and Gregory, to chase him down, is going to have to head south on North Street. Now, fortunately for us in this dreads problem, the diagram is provided for us. Now, they ask a question here about how fast is the distance between the two men changing? Well, remember the distance between 2 points is measured on a straight line. So we're going to say the distance from Gregory to Matthew on a straight line, and let's call that S. So slanted, hypotenuse, diagonal, whatever letter you want to use is fine. Let's call this variable distance G, because this is changing, Gregory's changing. Let's call that G. And this variable distance for Matthew, let's call that M. At this snapshot, Gregory is 3 miles from the intersection, and Matthew is 4 miles from the intersection. As Matthew continues to walk and Gregory continues to move, that distance is changing. Okay. So now that's our diagram. Let's set up the rates that are provided. It tells us that Gregory, when he's 3 miles away from the intersection, is going to be traveling 40 miles an hour. So that's Gregory's distance. Let's call that dg dt. The change of Gregory's distance with respect to time. Now, here's where you're going to have to be careful. A lot of people are going to want to say that his rate of change is 40 miles per hour. But technically, since G is decreasing in value from 3 miles, then down to 2, then down to 1 because of the direction, we're going to call dg dt negative 40. Okay. And then let's also write Matthew's time. dm dt, how fast is he going? Going 25 miles per hour. His distance is increasing for dm dt. All right. Now, we're in business. Let's set up an equation. The distance here, it looks like you're dealing with the diagonal of a right triangle. So we can use the Pythagorean theorem. I'm going to say g squared plus m squared equals s squared. All right. Let's get to work. Finding the derivative now. Let's see, we're differentiating with respect to t. So the derivative of g squared is 2g dg dt. That's the derivative of m squared is 2m dm dt. This is going to equal the derivative of s squared, which is 2s ds dt. Whew. And I just realized something. We're missing, I failed to write something down here. When we list our rates, we should list the missing rate. They want to know what's the rate of change of the distance between them. What's ds dt at this point when g equals 3 and when m equals 4. Okay, now we're going to do the last part of our dreads, and we'll substitute and solve. Let's see, 2 times 2 times g, looks like g is 3 at this moment. G dt is negative 40. Plus 2 times m, let's see, m was 4 at that moment. dm dt was 25. That's going to equal 2 times s. We're going to need to calculate ds. And we don't know what ds dt is. That's what we're solving for. So to find s at this moment, let's use the Pythagorean theorem. G squared plus m squared equals s squared. Well, g is 3. 3 squared plus m is 4. 4 squared equals s squared. 9 plus 16 equals s squared. 25 equals s squared. 5 equals s. All right. Now it's just algebra time. 2 times 3 is 6, times negative 40 is negative 240. 2 times 4 is 8. 8 times 25 is 200. 2 times 5 is 10. A little more room. Negative 240 and 200, call that negative 40. Divide by 10. We have enough room here? Sure we do. Negative 4 equals ds dt when g equals 3 and m equals 4. Now, let's see if this answer matches one of the options. Negative 4, and if we include the units, of course we would. This would be negative 4 miles per hour. Let's see what this matches. Let's see. Well, they're getting closer at 4 miles an hour. That means their change is negative. They're getting closer. So we're going to go with answer A. There you go. Thanks for watching the video, guys. Hang in there. Keep working hard. Your hard work will pay off. Have a good day.